So we are live on YouTube.
Yeah, okay.
Yeah, you can start. As of now, there are no questions in Google response sheet, sir. So we are waiting on YouTube chat, the students' queries, sir.
Do I need to go to the YouTube
Not
or
required, sir. Not required, sir. If anybody posts the questions on YouTube chat, I will put it over here, sir, in Zoom chat
okay.
itself.
Okay, all right.
Thank you, sir. Thank you, sir. Hi, participants. Professor Ashish Garg, sir, of Solar Photovoltaics Principles, Technologies and Materials course is here with us. Please post your queries in the YouTube chat. Thank you. Excuse me, sir.
Yes.
One student named Kundan Kumar Jha has posted, please explain AAA solar simulator.
Okay. So how do I do that? I mean, is it? Should I do it writing or should I explain it verbally?
Explain it verbally, sir. Yes, sir. In case if you want to write also, you can write, sir.
Okay, all right. Okay.
Right, sir.
So should I write it here or there?
Okay, you wanted to write it in YouTube chat itself, sir?
No. So basically, you can say any solar. I can speak verbally. I think they are watching
Right.
me, right?
Yes, sir. Yes, sir. They all are watching you, sir.
So basically, a solar simulator that works in all the three dimensions is called as AAA solar simulator. So essentially, that is the most basic definition that I can give for a AAA simulator. And it has a certain circular area and through which it measures the device.
Thank you, sir, for answering the query. Students, please post your doubts without any delay. Otherwise, we may end the session soon. Please utilize sir's time. Thank you.
The only thing I would like to make a difference, the solar simulators have different classes like class A plus, class A, class B, class C. There is also a class U. And it is related to spectral match. For example, in class A plus, the spectral match is over a wavelength range of 0.875 to 1.125. Whereas in case of class B, for example, the spectral match is from 0.6 to 1.4. And it is also related to spatial non-uniformity of radiance. So if you have A plus, then radiance uniformity is much better as compared to class B. So these are all different standards. They are related to basically the quality of spectra that you get, quality of radiance you get, the spread in the radiance that you get, and so on and so forth. All the class A specifications basically will be in the AAA category. And other parameters that you can possibly look at are, for instance, spectral content, spectral uniformity, spectral stability, with respect to time, as well as spectral coverage and deviation. So these are certain parameters. And if all the dimensions are matched, then we call it AAA simulator. I've also posted a written answer here. Okay.
Excuse me, sir.
Hmm.
Mr. Kundan Kumar Jha has posted another question. Please explain 1-5 characteristics.
IV characteristics. So IV characteristics are the characteristics between, it's a plot of current versus voltage. So for a diode, you have IV characteristics, which is basically diode in dark. You get a large exponential current in the forward bias, and you get very small current in the reverse bias. Writing on the board will be more useful. Okay, let me check. How can I write on the board here? Is there something for? Can you see my whiteboard?
Yes, sir. I'm able to view it, sir.
So can they see?
Yeah, after some time they will be able to see, sir. On YouTube, there is a delay, no, sir, in streaming.
So this is IV curve. So this is I, this is V. So for a diode in dark, you get exponential current like this. But for a diode in light, you get a curve like this. So this is light and this is dark. And LIGHT. Okay. Now, this is basically for a PN junction. So PN junction diode has a large forward current, positive current in the dark under forward bias. But when you shine it with light, the same IV curve shifts to fourth quadrant. So this curve basically shifts to fourth quadrant. And the current that you get at zero bias is a negative current, which is called a short circuit current. And the voltage at which the current is equal to zero, it's called as the open circuit voltage. So this point will be open circuit voltage. And this point will be short circuit current, ISC. And it is the area under this curve for a rectangle that can be drawn that will determine how much power, maximum power you can draw out of a IV curve. I hope that is clear. But this curve that you get is only for, so this, let's say, let me change the color. So this curve that you get is observed when you throw light on the PN junction diode. What do you mean by solar principles and technology? I mean, that's a very broad topic. What exactly do you want to hear? This is a question for Prashant. I think Prashant has to make his question a little bit more clearer. I see you in a little while. I'm in the middle of a lecture. Let me just open one more. Okay, so if I look at the second page, solar cell diagram, circuit diagram is you have a solar cell which is like this. Okay, so this is, let's say, the solar cell. Then we have a diode that is in parallel. And then we have a shunt resistance which is in parallel here. Then we have a series resistance. Okay, so this is your this is the direction of your JD. Okay, this will be direction of your JSC. This is your series resistance, and this is your shunt resistance. So basically, for a solar cell, if it's an ideal solar cell, you are going to observe only these two components. There will be no voltage drop across series resistance or the shunt resistance. There will be no loss of current or voltage. Now, when you have series and shunt resistance, so what happens in IV diagram, IV curve is, when you don't have a series and shunt resistance, then your curve is very square. So this is your IV curve. Series resistance is the inverse of slope of this point, and shunt resistance is inverse of slope of this point. So for a perfect IV curve, your series resistance will be equal to 0 and shunt resistance will be infinity. But if you have an imperfect IV curve, then your plot will look like this. So you have a finite slope at this point and you have a finite slope at this point, which means your series resistance is higher and shunt resistance is lower. And that is what we don't want. So this is 0 for ideal solar cell, and this is infinity for a ideal solar cell. And for a practical solar cell, it is greater than 0 for real solar cell, and it is less than infinity for a real solar cell. So this is what your diagram will. So basically, you can say that a solar cell diode will have two currents. One is the dark current, which is the bias-induced current. Another is the photocurrent, which is the light-induced current. And both of these are in the opposite direction. For a real solar cell, you will have parasitic resistances, which are called as series and shunt resistances. But for ideal solar cell, these will be series resistance will be equal to 0 and shunt resistance will be equal to infinity. As a result, your losses will be lower in the device. I hope that is clear. Prashant has to explain the question, explain solar principles and technology. That's a very broad question. I don't exactly know what you are asking. So you need to explain your question, or you need to clarify your question better.
Excuse me, sir.
Yes.
Mr. Kundan Kumar Jha has posted, what is accuracy in source meter?
Accuracy basically means that when you measure source meter, when you apply voltage, you measure the current, okay? And accuracy means that what is the accuracy of the measurement. So if you are measuring, let's say, a current of certain magnitude, let's say you measure current of few milliampere or microamperes, and what is the error bar in that current? And that depends upon manufacturer to manufacturer. For example, the one that we are using is Keithley. I think what is the model number? I will have to check, but it depends upon really let me check the model number. What is the source meter? Yeah, so we generally use Keithley 2400 SMU, that is source measure unit. And for that, if you look at its specification sheet, you will get the accuracy of measurement, that up to what digit the measurement is accurate. So it depends upon the brand. I mean, there is no one answer for this. It really depends upon the brand. But generally, it is in the order of microamperes accuracy It will be there. Let me just see if I have some number for 242600 series data sheet. Yeah, so it can measure the current ranging from 0.1 femtoamperes to 10 ampere. This is a new model. This is called as 2400B series SMU. SMU is source measure unit. 2600B is the model from Keithley. And this gives you a range from 0.1 femtoamperes to 10 amperes. So basically, the minimum current that it can measure is 0.1 femtoampere. So if you're measuring, so you can get an idea of error from that. And the voltages that it can apply is from 100 nanovolts to 200 volts. So basically, you can say that its resolution is down to 0.1 femtoamperes in current, and its resolution in current is voltage is down to 100 nanovolts. And you can say the resolution space will be approximately roughly six-digit resolution space. So these are very high accuracy machines. I mean, they give you very high, very good quality data and very accurate.
Excuse me, sir.
Yes.
Mr. Kundan Kumar Jha again has posted a question. The question is types of solar cell.
Types of solar cells are, there are three. Well, I mean, in general, we talk about solar cells in three generations. One is first generation technology, another is second generation technology, now third is third generation technology. First generation technology is generally based on wafer-based technology, which is on crystalline silicon and gallium arsenide, as well as polycrystalline silicon. Second generation solar cells are more called as thin film solar cells, which use thin film of inorganic compounds, which is about 2 to 5 micron thick, and these are based on cadmium telluride, copper, indium, gallium selenide, and amorphous silicon. And in the third generation, we categorize organic solar cells based on polymers, perovskite solar cell, which is based on perovskite dyes, or dye-sensitized solar cells. There are some other solar cells, which are advanced solar cells, such as quantum dot solar cells, plasmonic solar cells, tandem solar cells, multi-junction solar cells, which are all advanced solar cells. So this is how you basically categorize the different solar cells.
Thank you so much, sir, for answering that query.
Somebody's asked about a question paper. Question paper will be objective type or fill in the blanks. And
Thank you, sir, for telling the pattern. Right now, 4 are watching, sir, but they are not actively posting. So in that case, can we end the session now, sir?
yeah, that's fine. No problem. As long as you guys are okay with that.
Yeah. Or else let's wait for 2 more minutes, sir. In case if nobody posts, then we will end, sir.
Okay.
Right, sir. Thank you, sir. Sir, we can close now, sir, because no questions are posted.
Okay. We
Thank
can
you so
close it.
much, sir, for
Thank
your
you.
valuable
Thank you.
time. Thank you,